Hello everyone, so today I'll be covering question number 39 of set 2 gate 2022. A post-tensioned concrete member of span 15 meter and cross section of 450 mm by 450 mm is pre-stressed with 3 steel tendons, each of cross-sectional area 200 mm square. The tendons are tensioned one after another to a stress of 1500 MPa. All the tendons are straight and located at 125 mm from the bottom of the member. Assume the pre-stress to be same in all the tendons and the modular ratio be 6. The average loss of pre-stress due to elastic deformation of concrete considering all 3 tendons is. So 4 options are given to us. For this type of problems, you can refer to lecture series on pre-stressed concrete by Professor A.K. Sengupta, Department of Civil Engineering, IIT Madras. Let's start with the solution of this problem now. So in this question, it is given to us that the length of the beam or the span of the beam is 15 meter. Also, the cross-sectional dimensions are also given to us, that is 450 mm is the width and the depth is also 450 mm. Also, it is given that there are 3 tendons which are straight and are located at 125 mm from the bottom of the member. So, this distance is given to us, which is 125 mm. So, now we can calculate the value of E, that is the value of the distance of the tendons from the neutral axis. So, this value we can now easily calculate, which will be 450 divided by 2 minus this 125 mm. So, minus 125 mm. So, the value of E, that is the distance of the tendons from the neutral axis, will be now 100 mm. Now, let's see what are all the other things which are given. So, the area of the tendons is given to us, which is 200 mm square, which is the area of each tendon. So, it is 200 mm square. Also, the value of initial pre-stress. The value of initial pre-stress is given to us, and it is 1500 MPa. So, we can calculate the force in each tendon. So, force in each tendon will be area of each tendon multiplied by the pre-stress, initial pre-stress. The value of P, that is force in each tendon, will be 1500 Newton per mm square multiplied by 200 mm square. This value will be in Newton. So, if you want to convert it into kilonewton, we will divide it by 1000. So, the value of pre-stress will be 300 kilonewton. So, this is the value of pre-stress we are getting. In this question, we need to find the average loss of pre-stress due to elastic deformation of concrete in all the 3 tendons. So for that, let's see what is the elastic deformation loss. Okay, so when in the post-tension system, so it is given that this system is pre-stressed using the post-tensioned method. Okay, so in post-tension method, there can be 2 cases for the elastic deformation loss. The first case is when all the tendons are simultaneously stressed. All tendons are stressed simultaneously. Other case can be when they are tensioned one after another. So in the first case, when all the tendons are stressed simultaneously, there will be no loss due to elastic deformation of concrete. Why? Because the pre-stress will be measured after the stressing. So this elastic deformation loss won't be measured there. But when the system is tendons are stressed one after another, so what happens is, suppose there is a system in which there are 3 tendons. So in the system there are 3 tendons: tendon 1, tendon 2 and tendon 3. Suppose when the first tendon is tensioned, so there will be no loss due to elastic deformation of concrete, because the pre-stress will be measured after the tendon are stressed. But when the second tendon is stressed, so there will be elastic deformation lost in tendon number 1. Similarly, when the third tendon is stressed, there will be loss of pre-stress in first and second tendon due to elastic deformation of concrete. So in conclusion, when the first tendon is stressed, so in the first tendon the loss will be due to stressing of second and third tendon. For the second tendon, the loss will be due to stressing of third tendon, while there will be no loss in the tendon number 3. So there will be no loss in tendon number 3 because it is tensioned after these first and second cases. Now let's calculate the loss of pre-stress in tendon 2. Okay, so we know that the formula for loss of pre-stress due to elastic deformation of concrete is modular ratio times the FC. What is FC here? So FC is the stress in concrete at the level of the tendon. So modular ratio is already given to us and the value is 6. Now let us calculate the value of FC. So suppose there is a system here, there is the neutral axis and here is the tendon. So when we pre-stress it by P amount, and suppose there is E, that is the distance of the tendon from the neutral axis. So we can also make this system into, we can divide it into these 2 parts just for the sake of analysis. We are not actually doing anything, but just for simplification of the analysis we can write it. We can make this structure like these, like as a sum of these 2. So in this case what we will do is a neutral axis here, so we will shift this load P towards this neutral axis. So when we shift this load P, there will be the shifting happens as well as there will be a moment which is developed. So suppose there is this, now we have shifted it to the neutral axis location. Also there will be a moment which will be generated due to this shifting, and the direction of the moment will be towards this position. That is, we have shifted this load from the downward direction, so the arrow will be like this. That will be the moment generated. The magnitude of this moment will be P times E, that is the force which we have shifted multiplied by the distance by which we have shifted the load. So this system can be, we can make it like as a sum of these 2 systems just for the simplification of the analysis. We are not shifting the pre-stress force in reality. Okay, just for analysis purpose we can make it like this. So now we have to analyze these 2 systems. This we have done to calculate the value of FC here. So FC is the force in the stress in concrete due to at the location of the tendon. So due to this first system, what will be the stress in concrete? The stress in concrete will be uniformly P by A. Okay, because it's a compressive force, so stress will be force divided by the area of cross section. So due to this first case, the stress in concrete will be, so this is the for case number 1 and this is for case number 2. So for first case there will be entirely there will be a compressive force and the value will be P by A, plus this second case is also here. So due to the second case, this is a bending stress will be generated because we have applied a moment PE. So the value of bending stress is, we know that it is M by I multiplied by Y, where M is the value of the applied bending moment, I is the moment of inertia, and Y is the location where we have to calculate the stress. So here in this case we have to calculate the stress at the location of the tendon. So what will be the value of y here? The value of y will be E, right? Because E is at the location where we need to calculate the stress. Okay, so the value will be m. So what is the value of m? M is P into E divided by I, which is, let's keep it I for now, and multiplied by the distance where we have to calculate the stress. So we have to calculate the stress at a distance of E from the neutral axis, so it will be E. So this is how we will calculate the value of Fc. Now let us put all the values in the derived formula and calculate the value of Fc for wire 2. So value of P is 300. Let's convert it into Newton. 300 into 1000 divided by, what is the area, cross sectional area? Area of cross section is 450 into 450 plus P multiplied by E. The value of E is 100 here. Then there is another E, so 100 square divided by I. What is the value of I? I for a rectangular cross section is BD cube by 12, where B is 450 here. Depth is also 450 divided by 12. So solving it, we get the value of Fc for second wire as 2.36 Newton per mm square. So Fc we got as 2.36 into 10 to the power 2.36 Newton per mm square. Now we can calculate loss of stress in wire 2 due to elastic shortening is m into Fc. What is the value of m which we have given? We have given the value of m as 6, so 2.36 into 6, and finally we get our answer as 14.16 Newton per mm square. Now let us calculate the loss of stress in wire 1 due to elastic shortening. So as I've told earlier also, the loss of stress in wire 1 will be both due to stretching of wire 2 and wire 3. So loss of stress in wire 1 will be due to total of force P2 and force P3. So total force due to which the loss will occur is 600 kilonewton in wire 1. So we'll use the same formula here. So loss of stress in wire 1 will be m into Fc. So m we already know it's 6, and Fc we need to calculate. You will use the same formula as here. So Fc will be equal to P by A plus Pe by I into E. Here P will be 600 kilonewton now. So Fc is 600 divided by the area is 450. So I'll convert it into Newton also. So 450 into 450 plus 600 into 10 to the power 3 multiplied by, what is the value of E in this case? In this case also the value of E is 100 mm only, because all the 3 wires are at the same location from the neutral axis. So E is 100, so they are E twice, so 100 square divided by area by moment of inertia. Moment of inertia is BD cube by 12. So solving it, we get the value as, we get the value of Fc as 4.72 Newton per mm square. Now we can calculate the value of loss of stress in wire 1. So loss of stress in wire 1 will be m into fc, that is 6 into 4.72, and we'll get the value as 28.32 Newton per mm square. But we need to calculate the value of average loss of stress in all the 3 wires. So in wire 3 there is no loss, and in wire 2 we calculated the loss as 4.16 Newton per mm square. In wire 1 we calculated the loss as 28.32. So average loss of stress in all the 3 wires will be sum of stress in all the 3 wires divided by 3. So 0 plus 14.16 plus 28.32 divided by 3. So average loss value will be 14.16 Newton per mm square. So this is the final answer we got. The value of average loss of stress in all the 3 wires is 14.16 Newton per mm square. So the option will be option number A.